For question 11, we want to determine if p is a function where p has been defined as a relation from the positive real numbers to the set of real numbers such that for all real numbers x and y, with x being greater than 0, x comma y being in set p means that x equals y squared. The definition of function from your textbook, this is on page 17, it says that a function f from a set A to a set B is a relation, so P is a relation, we've got that, with domain A. So I will write down here at the bottom that our domain is the set of positive real numbers. And the codomain is the set of real numbers. And these need to satisfy the two properties. For every element x in A, there is an element y in B such that x comma y is an element of the function. What this is telling us is that every positive real number x has to correspond to some real number y such that x is equal to y squared. That's our definition for p. Let's choose some values for x and see what we get here. I could choose that x is equal to 4. Then y could equal 2 because we know that 2 squared is 4, or y could equal negative 2. So do we have a value for y when we have a value for x? We do in this case. 4 is a perfect square. What if we have a number that's not a perfect square? Let's take x equals 5. Well, then y can equal the square root of 5, or y could equal the negative square root of 5. So that's fine. What we're doing here is we're checking to see if there's any number that we can choose that's a positive real number that is going to make this fail. And so far we haven't been able to do that. Now, just by citing a couple of cases doesn't prove what it is we're trying to determine, but what I can do is think about, is there any other real number that would have some kind of property that would make it fail in this case? And there isn't one. So it's going to satisfy part 1. Every element in the set of positive real numbers has a corresponding element in the set of real numbers such that our first number is equal to the square of the second number. So we've got part 1. Now let's take a look at part 2. I'm going to make some room here. It says for all elements x in A and y and z in B, if xy is an element of f and xz is an element of f, then y is equal to z. So let's go back to what we just had a minute ago, where x is 4, and that means that y could equal 2, or y could equal negative 2. Notice now that I have two values for y, and they're not equal to each other. This tells me that p is not a function. And that's the end of that problem.